Zen imaging software from Carl Zeiss provides a number of methods of quantifying image data. This tutorial is intended as a follow-up to the previous introductory walkthrough of the image analysis module and assumes the viewer is familiar with the basic concepts of thresholding or segmentation, filtering, and reporting of data. Here we will extend those concepts by involving two fluorescent channels in a zone of influence, scoring the events in a nuclear translocation assay where cytoplasmic protein localizes to a nucleus as a result of drug treatment. As noted here, thanks to the folks maintaining the broad bioimage benchmark collection, the source for these images. The automated image analysis module is accessed under the Analysis tab in the window titled Image Analysis. Let's begin by creating a new analysis configuration and name it appropriately. I'm calling my configuration NucTrans. A characteristic of the zone of influence analysis is that we are examining signal outside of the primary mask. That is, once we identified the object of interest, we are capable of examining signal outside of that object as well as inside the object. In order to employ this, we need to change the method of analysis here on the first page. Click on this pencil icon underneath the configuration name and you will see a list of analysis methods available. We will be using the ZOI or zone of influence. You can see that the layout of the class structure immediately changes to reflect this new method. Let's continue to the setup by clicking on Setup Image Analysis. The sample that we are using has two channels, a nuclear DAPI stain in channel named C1 and a GFP fusion protein named here GFP. Our primary task will be using the DAPI channel, so I will first ensure that channel C1 is selected for the primary object class. I'm going to rename the primary object nuclei, and then under the ring element, I'm going to label this cytoplasm. My mask color for nuclei is orange, and my mask color for cytoplasm is pink. Step 3 of the analysis wizard is where we see the zone of influence really deviate from the other methods of image analysis. Setting the threshold on the DAPI channel, we see the nuclei are easily detected as one would expect. However, we have these concentric circles around each nucleus. If I zoom in, you can see that each nucleus has a double pink circle. This defines the region that is going to be quantified as the cytoplasmic region. There is no thresholding occurring in the cytoplasmic ring region. It is simply a matter of a donut shape defined relative to the nucleus by dilation. The inner circle of the donut is defined as a ring distance from the nucleus, and the outer circle of the donut is defined by the ring width parameter. It is important to note the inner circle can be defined as a negative term, in which case it will exist within the nucleus as a sort of erosion of the nuclear boundary. There are two yellow circles as well, as you can now see. These represent the zone of influence, or ZOI class for analysis. The inner yellow circle is fixed at the boundary of the nucleus, or the primary object, while the outer boundary is defined relative to the outer boundary of the cytoplasmic ring. For our purposes, we can derive all information we need from the nuclear and cytoplasmic classes. We will not bother with reporting data from the zone of influence. In step 5, we will define the values we are interested in quantifying. Because this is a nuclear translocation assay, we are interested in measuring quantity of green fluorescence in the nucleus versus the cytoplasm. For that reason, I will report the mean fluorescence intensity of the GFP channel in both the nuclei class as well as the cytoplasmic class. You may have noticed that both the nuclear and cytoplasmic classes are defined as subclasses of the zone of influence. For simplicity of reporting all measurements on the same table, I'm going to make sure I copy all the measured intensity data to the ZOI results table. Finalizing the configuration and analyzing the image allows me to see the results in a scatter plot, where I'm going to display the mean intensity of nuclear versus cytoplasmic signal. The real power in this comes when comparing the results to a treated sample. Running the identical analysis on a treated control sample, where almost all the signal is found in the nucleus, gives us a very different looking plot. Note the scale on the y-axis is half that of the untreated sample, meaning the ratio of cytoplasmic versus nuclear signal is much lower in the treated sample, as is expected. Of course, as shown in the introductory tutorial, this data can now be easily exported by creating a table document and exporting as a CSV file to open in Excel. With that, we can conclude our walkthrough for using zone of influence image analysis. Look for further tutorials on powerful tools within Zen image analysis, and until then, enjoy your time exploring Zen.